Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the thermal coefficients. The partial derivative of measurable properties P, V, or T is not only measurable, but also has a clear physical meaning. The physical quantities composed of these measurable properties with clear physical meaning are collectively called the thermal coefficients. In single-phase regions, pressure and temperature are independent, and we can think of the specific volume as being a function of these two. V equals V T P. Try to write the expression for dV. Now we introduce definitions for the four thermal coefficients. Being an indication of the change in volume that occurs when temperature changes while pressure remains constant. The volume expansivity, also called the coefficient of volume expansion, is defined as being an indication of the change in volume that occurs when pressure changes while temperature remains constant. The isothermal compressibility is defined as being an indication of the change in volume that occurs when pressure changes while entropy remains constant. The isentropic compressibility is defined as being an indication of the change in pressure that occurs when temperature changes while volume remains constant. The relative pressure coefficient is defined as. Firstly, let's talk about the volume expansivity, alpha V. The unit for the volume expansivity is seen to be the reciprocal of that for temperature. Commonly, we have positive values for the volume expansivity, but water and some alloys, the specific volume decreases with increasing temperature under constant pressure, that is, the negative volume expansivity. For ideal gas, the volume expansivity is 1 over T. Secondly, let's talk about the isothermal compressibility. Its unit is the reciprocal of that for pressure. The isothermal compressibility should be larger than 0, which is the necessary condition for the stable existence of working fluid. For ideal gas, the isothermal compressibility is 1 over T. Thirdly, let's talk about the isentropic compressibility. Its unit is also the reciprocal of that for pressure. The isentropic compressibility should be larger than 0, which is the necessary condition for the stable existence of working fluid. Try to prove the above expression and derive the isentropic compressibility for ideal gas. Finally, let's talk about the relative pressure coefficient. Its unit is the reciprocal of that for temperature. The relative pressure coefficient should be larger than 0, which is the necessary condition for the stable existence of working fluid. For ideal gas, the relative pressure coefficient is 1 over T. These thermal coefficients can be determined by experiments or can be obtained by the equation of state. The relationship between them is. This relationship can be derived from the cyclic relations. Try to do it. These thermal coefficients have obvious physical meanings and are composed of measurable properties, so they are widely used. For example, the thermal coefficients are determined by experiments, and the equation of state is obtained according to the integral. Okay, that's all for this task. Thank you very much, and see you next time.